much for coming over here.
God, I'm so glad I'm here, and I'm so relieved. You know, we have a space mission. We're in touch with the spacecraft, you know, and everything is nominal. We're waiting, of course, for the second burn, but not quite there, but we're really close.
Yes. So can you tell us what makes going to Mars incredibly hard?
So there's really two pieces that make it hard. The first one is what we're doing today, which is you really need to head in the right direction. Yeah. So take it off the Earth and have a lot of energy and head exactly in the right direction, because what you want to make sure is in February, when Mars comes, you want to be right there so you can get captured. The second one, which is the one that's going to make us nervous in February, is to entry, descend, and land. You know, so the Mars atmosphere is almost the worst of all worlds. If it was really thick, you could do what we're doing on Earth, which just go in and with parachute. Yeah. If there was none of them there, you could do, you know, what we do at the moon. When in Mars, you have to do both on top of each other, which makes it 10 times harder than any of the other two, and so that's what makes it so hard.
Wow.
You've devoted much of your life to science, and I know you were asked the other day during a news conference, you know, why another rover, and you gave a pretty impassioned response. Why is this rover important in your mind to the work that so many people are doing in science?
So it's really kind of a key of a whole bunch of new research that we're doing that is focused on a question that for thousands of years philosophers have asked, scientists have asked, and we're ready to answer with the tools of science, which is the way to get reliable answers. And that is there life out there? We have, for 20 years, we've learned about the environment at Mars, and we're ready to ask that now. And the way we're doing it is with this rover. So it's really, for the first time in decades, the first astrobiology mission. We're ready for it, where it's the next step, and of course there's others coming, you know, Dragonfly, we're already thinking about, and you know, other missions. We want to, of course, go to Enceladus in Europa, you know, and really learn about life there also. So it's an amazing first in that respect.
And whether there's life there or not, that's going to be the answer that we're looking for in these places.
So yeah, exactly.
Yeah, and so we want to do a social media question real quick, if that's all right with you.
Oh, absolutely.
All right.
We have a question from Twitter. What is the key difference between previous NASA missions, rover missions, to Mars, like Spirit, Opportunity, Curiosity, and Perseverance Rover? In what way is Perseverance unique from the previous ones?
So there's a fundamental difference in the approach. And the fundamental difference is that we decided to put the instruments on Perseverance, the best geology instruments on this, so we can find the right samples. And we decided not to put a chemistry lab on it. Guess why? We don't know which one yet. And so what we're doing is we're actually collecting the samples that we're going to bring to the best labs that are available to humanity, which are the labs all over the world. And that's the choice here. And that's, of course, to do that, we need to do another first, which is humanity's first round trip to another planet. And that's what makes it different.
We've got more with the launch operation to go, but real quick, how'd you feel about that launch?
Oh, I loved it. It's like punching a hole in the sky, right? It's really getting off the cosmic shore, our Earth, into wading out there into the cosmic ocean. I just love it every time it gets me.
All right, very good. Dr. Thomas Zurbuchen, thank you for joining us. We appreciate you being here to explain all the science and the excitement that's coming up.
Thank you so much.
Appreciate it. Now we've talked to scientists and engineers, and we have shared highlights of the mission and tech demonstrations that are central to the Perseverance rover. And folks, we have a lot more to share.
Mars Perseverance has been flying in space for more than a half hour now. Let's check back in with Joshua and Mick to recap the flight so far and tell us what's coming up next.
Hey, thanks, Moo. Yeah, as you're seeing on screen there, that is, again, the animation of the Centaur in motion around Earth, in orbit around Earth. And you can see there, like I mentioned, the animation being driven by real telemetry data. Mick, how is the report coming back from the first burn and then currently our coast phase?
So we're hearing from Jesse Gonzalez and the engineering team is that everything so far has been nominal. Centaur's been performing well. All the settling firings have been going great, which is keeping the fuel that's still in the tank where it needs to be as we get ready to come up on main engine start 2 for that second burn, which is very important to get us our velocity and into that transfer orbit to Mars.
Yeah, so that will be up in just a few minutes, but I think we're going to actually send you back out to our main desk to hear. Oh, so sorry. I'm being held. We're going to hang out here. So coming up, so talk about C3, Mick. This is something that we talked about having to do with the energy to leave Earth and go somewhere else. We're talking about having to get to speeds over 25,000 miles per hour. That's Earth's escape velocity.
Yeah, so C3 is basically just the technical term that we use in the aerospace industry to refer to the velocity that we need to get the vehicle where it needs to be. So as you said, we got that little over 2 million pounds of thrust that we left Earth this morning with those mighty 4 solids on the Dominator. I still like that from Tori Bruno. Tori, I'm gonna take that one from Tori. But we got off here and into the park orbit with the proper velocity we needed. And then, of course, this second burn is so important for the velocity we need to get in transfer orbit.
Awesome. So the Dominator punching a hole in the sky, as Dr. Zurbuchen said. So we will send it back out now to the main desk and be back with you in just a minute to catch that second burn. Daryl?
All right, thank you very much.
Thanks so much, Joshua. Joining us now to talk about how special these missions are is Dr. Michael Watkins. He's the director of the Jet Propulsion Laboratory in California, which planned Perseverance's mission to Mars. That is my home center. Thank you for joining us, Dr. Watkins. So we have so many great questions for you. Why are missions to Mars unique?
Well, I think they're unique for 2 ways. And one is just Mars. It's been in our imagination for centuries. It's a place that looks like the Earth. It looks like it could be home to us. It looked like it was once home to what could have been life. And the fact that we can get there, and we can get there every couple of years, and we can send missions, and we can build on those missions, and you can learn from your mistakes. You can learn from your successes. One of the things I like to joke about is, we say Perseverance looks like Curiosity, but the people who built them are the same. They look even more like each other. And so they, so a lot of our folks worked on Mars Pathfinder, they worked on Spirit, Opportunity, they worked on Curiosity, and now Perseverance. And that history, that group of folks, they're just world leaders, and it's why we're successful.
So you oversee the Jet Propulsion Laboratory in California and doing incredibly complex work. Why are these robotic missions so hard?
They're hard because you can't really see what's going on. You can't use your human responses, right? You're used to driving your car and you see what's happening, and you turn the wheel. In this case, we've got to tell the rover, we've got to prepare the rover to do a lot of that stuff on its own, right? And so we've got to understand Mars, we've got to understand how the rover works, and we've got to put all that together into a machine that can function more or less without us. So we talk to it once a day, and we say, how are you doing, and go over there and do these experiments, and then it's got to do that. So, we kind of give it its intention, but then it's got to do all those activities by itself, and that's a challenge. And the further away from the Earth you get, the harder it is. So you get out to Saturn, you get to Europa, you get beyond, and it becomes harder and harder.
Yeah.
Real quick, one question to wrap up. You've been in touch with the folks out at JPL. On air, there was an earthquake that played out. It was a 3.9 magnitude. How is everybody doing? How's your team?
They're doing great. Our view is it's just Pasadena. It's just the Earth being excited about going to Mars. So it was a very minor earthquake. We have them a lot in California.
Okay.
Maybe it's like hurricanes here or something, but it's tropical storms here. But it was a very minor event, and everything's fine. And we are on our way to Mars.
Okay, so a little rumble here in Florida, some rumble in California. It works out great. Mike Watkins, thank you so much. We appreciate you joining us on the broadcast.
My pleasure. Thank you.
All right.
Awesome. We will have that conversation with Zena Cardman coming up, which I'm super excited about.
That's right.
Yeah. On the other side of the Centaur burn and spacecraft separation. We'll also highlight 6 major technologies that NASA's focusing on over the next decade, including the critical energy needs for such missions. But with that, let's turn our attention to the next operational steps. Joshua, are you there?
Yeah, Moo, we're here and we're excited. We have a fuel pre-start call just coming in. We are getting ready to hear the call for this second burn of that Centaur RL-10 engine. Again, Mick, explain what this second burn is for.
So as we talked earlier, the second burn is really to get us that velocity as we head into that transfer orbit, right? Centaur and Mars 2020 will head into that solar orbit on its way with the proper velocity. We will then get ready to separate Mars 2020 on its way. And I'm hearing that settling is done, and we have main engine start.
There we go. Awesome. And again, that animation there being driven by actual telemetry data coming from that
Here we
rocket.
go, guys.
So
we have the second engine startup.
And again,
Seconds
it's
time the
tough.
engine
These
starting
images,
up.
Perspective and scale are so important. This vehicle is in Earth orbit. It's not near anything, so you can't see the acceleration of what's happening right now. But for 8 minutes, it's going to be picking up speed.
Yeah, this is the burn that gets us really moving in the
Just
direction
see
we need
the
to go,
apogee,
that
guys.
fast velocity that we need to get out of our park orbit and head on our way to Mars. Of course, Centaur and Mars 2020 are still together, and as we're hearing, everything
You
is
see
looking
it, guys,
nominal on this
guys,
fire
apogee.
so far. The main engine start was good, and the firing is going well, nominal, as we see in the animation there.
On the top
Fantastic.
right.
So this is rocket science, and it's not easy. We actually want to bring in now, we have a special guest. This is Dr. Denton Gibson, excuse me.
Yes.
He is a rocket scientist. His official title is Senior Vehicle Systems Engineer. Denton, how are you doing?
I'm doing well. Thanks for having me.
Yeah, did you enjoy that? Obviously, you got to kind of spectate. A lot of days, you guys sitting on console, you have to kind of focus on your computer, but you got to see this one today.
Oh, yes, and it was a beautiful launch today.
Yeah, nice sunrise. Hey, tell us about your role with LSP. I was not making up things when I said you're a rocket scientist, but what exactly do you do?
So as our role in LSP, as a vehicle system engineer, we are the engineering team lead for a lot of the rockets that we launch our science missions on. And we are responsible for the oversight and insight into these launch vehicles for the NASA.
That's awesome. And I know in the past you've supported a variety of vehicles. Tell us a little bit about the vehicles that you have supported and the ones you're focused on today.
Yeah, so some of the vehicles I supported in the past is the Delta II, which was a long-time workhorse for our science missions, as well as the Pegasus and Taurus/Minotaur C. And right now I've been focused mainly on the Falcon 9 and Falcon Heavy.
Yeah, awesome. So obviously not focused on the Atlas V, but a lot of that experience and the process is the same. I want to take a moment to pause and say Denton's there at Hangar AE. That's the NASA Launch Services Program's hangar. They're very proud of that. We call it the telemetry center of the universe. That's where the data for today is flowing. But I wanted to also ask you, is the process the same for all these vehicles? When we talk about the telemetry and these sort of processes of getting from Earth to Mars, does Falcon 9 experience translate to Atlas, or are they completely separate?
So the overall process for many of these launch vehicles are the same, whereas you ship stages to the launch site and assemble the launch vehicles by stages. So in that sense, they're the same, but there's a lot of differences between the launch vehicles that may change that process a little bit. But in general, the processes are the same.
Yeah, and Joshua, I was going to say, Denton, I work with Denton quite a bit over the years, and he talks about the different vehicles he's worked on. But Denton is one of my senior vehicle engineers in LSP, and so although he's not totally supporting Atlas V today, he does have experience with Atlas V, and as he said, things are very similar. So using his experience, we're able to train and bring on new generation of engineers, and Denton's been a huge part of that to allow us to grow our bench, if you will, to start working commercial partners.
Yeah, awesome. So Denton, tell us a little bit about kind of what's involved, what goes in behind the scenes, what's the rocket science of going from Earth to Mars, this maneuver to go into solar orbit?
Yeah. So a lot of the things that happen behind the scenes it's a lot of analysis work done by our analysis teams. I mean, it's months and months of analyses that are performed based on the orbit insertion, the performance of the launch vehicle. A lot of modeling and simulations is done to be able to get to this point to where we can transfer from Earth orbit into solar orbit.
Awesome. And obviously, you're a rocket scientist. That's for a lot of people, that's like the pinnacle. That's like, hey, I want to be a rocket scientist. So where do you go from here in your career? Because obviously, like, I'm sure there's lots of things that you'd like to go and accomplish.
So, going from here, I mean, one of the coolest things about this job of working in the launch services program is working the launch, right? I mean, who doesn't love a launch, and who doesn't love working launches?
Yeah, we love them. We love them. Excitement this morning, right, Denton? We got to see that's what it's all about.
Of course. So, one of the ideal jobs would be a launch director, because you get to work all the launches. I mean, how cool is that?
No, yeah, that's true. And I guess you get to, is it right to say you call the shots, or is it that the buck stops with you, or how would you say that?
I'd say the buck stops with the launch manager. As today we talked, right? Omar Baez is our launch manager for Mars 2020, and he had to poll the team and make sure everything's ready to go. So the buck does stop with him right there on today's launch. And as Denton says, I think there's a lot of people that would love that job, and Denton's definitely looking at that next step. So I guess we need to give Omar and his assistant launch manager, Tim Dunn, a heads up.
Yeah, there you go.
That,
Dr. Gibson.
Dr. Gibson is
Up
on
and
the
coming.
way. Yeah.
Awesome. Well, Dr. Gibson, before we let you go, give us a real quick snapshot. I know you have a mission coming up later this year. What are you working on?
So, we're supporting the Crew 1 launch coming up. So we're helping commercial crew out with that one, as well as Sentinel-6 as far as the LSP missions that's coming up later on this year. And so we're excited about that one.
Yeah, a ton going on. Dr. Gibson, appreciate you. Thanks. And I want to take a special moment on the commercial crew note to comment. We've got a big day coming up.
Yes.
Pending weather. There's a tropical system that might kind of get in the mix here, but we have a tropical system that could create some problems. Otherwise, we've got Bob and Doug from Demo 2. They're coming home on August 2nd.
Yes, I was going to say, Joshua, that's important for us also in LSP. Denton was my lead VSE, along with a few others that are in the group that worked that mission with the commercial crew program. And so it's really important for us to be able to support other programs within the agency to make these things happen. As we launch Mars 2020 today, which is another step for us getting humans to Mars, right, is getting humans launched off of Earth soil was a huge step for off of American soil.
Yes.
was a huge step for us.
Yeah, and so talk about that really briefly with LSP. Obviously, Denton there, appreciate him and his contribution, and you working towards commercial crew, but also supporting Artemis, which is also part of that path of getting humans to Mars someday. Artemis is about learning to live on the moon to sustain a presence there with the eyes on Mars. So how is LSP supporting even Artemis?
Yeah, one of the things there is the Gateway program, right? Deep Space Logistics that is working a lot of that. And so LSP is in the works of supporting Gateway and helping them work with the commercial partners that are providing the rockets for those kind of missions that are out there and future things. One of the cool things about working with the Launch Services Program is that we work with all of our commercial partners, SpaceX, United Launch Alliance, Northrop Grumman Space Systems, and of course some up and comings. You may have heard some, right?
It is
like
a growing
Blue Origin.
field. Yeah.
It's definitely a growing field in the aerospace industry, and LSP takes pride in working with those commercial partners to figure out what we can do for NASA and the country.
Awesome. Yeah, it is an exciting time for spaceflight. The commercial spaceflight industry is booming. There's always new things happening. If you keep an eye on the news, you will see new things. We're getting word now that the engine cutoff here should be happening momentarily. Once we see that happen, we'll have roughly, I believe it's 5 minutes until we actually see the spacecraft separation occur. So we're going to stay with you through that, but want to kind of just preview that for you, that hopefully on screen here, you should be seeing that engine cutoff, and that's completely expected. That's a nominal operation, as you say, Nick.
We'll hear from Jesse Gonzalez, who's looking at the launch vehicle telemetry and watching the animation there. So let's listen in for Jesse here.
And there's the call, and there's the animation, again, modified based on data. So
shutdown parameters
let's talk about communication for a minute, Nick, because it is not an automatic thing to just shoot information at Earth and have that be usable. So how do we go about communicating not only through launch, but on the way to Mars, and then once we're at Mars?
Yeah, so the important thing this morning is when we lifted off from Complex 41 here at Cape Canaveral Air Force Station, we had ground stations that were looking at the launch vehicle and tracked it all the way to provide data. Once we got onto orbit after stage separation, you heard a call out for TDRS, the telemetry network that NASA owns, which, by the way, is also used for the ISS and will be used hopefully for the landing with Doug and them.
Yes.
So getting off the ground today was great because we could deconflict some of that TDRS usage, right? But TDRS is very important for us to be able to get the telemetry from the launch vehicle back down to Earth here. And then, of course, when Mars 2020 separates and it gets on its way to Mars, then the JPL team will take advantage of NASA's Deep Space Network, which has been around for a long time, to be able to transmit commands and data back and forth to the Mars 2020. So it takes a lot of folks to work those, and the TDRS and Deep Space Network are very important to not only the science missions, but human space flight also.
Yeah, and I think the coordination of that is something that people don't get a chance to understand much, because as you said, we're using TDRS for crew return, we use TDRS for space station, and TDRS is not an unlimited resource. We have a good number of TDRS satellites in orbit that help us do these things, but it is a coordinated effort across the globe, because we even have ground stations in Australia, I think.
Yeah.
Where are all of our ground stations even?
We have ground stations everywhere, not only here in America on the West Coast and East Coast, but then you get into South Africa area, Australia, you said. We have several ground stations that catch up different things for missions. But, of course, in orbit, TDRS and the Deep Space Network are very important. And as you said, there's not an unlimited amount of resources there in the TDRS network. So we have to coordinate those things within the NASA agency and with our commercial partners when they're used for our launches. And again, that's another part of what NASA does as an agency.
Yeah, so just on that note, kind of thinking about around the world, currently this spacecraft is roughly over the South Indian Ocean. So that's just thinking about how fast we're moving, just the amazing world of spaceflight. It's just hard to put into words sometimes of like, we're literally flying around the Earth and we're already halfway around it. And so I want to talk actually about planetary protection some more. I know we heard about that a little bit from Moo, about how they're working to protect Mars from contamination, so to speak, just putting things there we don't want, and we have to consider that, or ULA has to consider that when they're flying to Mars and delivering the spacecraft.
Yeah, it's a combined team. ULA, JPL, LSP had to look at that for when we get ready for spacecraft separation here in about a minute, right? One of the things we talked earlier is that Centaur and Mars 2020 are on the same path towards Mars right now. So once we separate, Centaur will do a CCAM maneuver, or what we call a contamination and control avoidance maneuver, and then blow down what's left of propellants in its tank. And by doing that, we have now put Centaur on a different track so that it will not intercept Mars or interfere with Mars 2020 at all for approximately the next 50 years.
Yeah.
And that took a lot of work by the JPL team and the launch team to make sure that would happen. So again, another planetary protection maneuver that had to be done.
Yeah, and I understand from the telemetry experts in LSP that this rocket actually, after the second burn, is not actually aimed straight at Mars for that reason. It's actually aimed slightly off of Mars. And so Perseverance, Mars 2020, will redirect itself just slightly. We're not talking about over 7 months. A little bit of difference here makes a lot of difference later.
Absolutely. And Josh, we heard Jesse telling us that Centaur is spinning up. This is the maneuver right prior to spacecraft separation, where we get into a slight roll to give Mars 2020 some
stable Centaur tank pressures,
stability.
Very good performance from the RCS system, and stable indications from the avionics systems as well.
So RCS there, the reaction control system, that's those small, the series of those small engines that you see firing around the spacecraft. Those are used for that in-flight operations that they need. The rolling activities, as Mick's saying, is basically providing stability to the flight of Mars 2020 as we go forward. Tell us about actually...
And we have successful separation of Mars 2020 with the Perseverance Rover.
There we go.
Awesome. We got some nice applause there. That is a big moment. We are hoping to get some live video back from that.
Here we go, guys. We have the separation confirmed.
We don't have it at this instant. We're hoping we'll get to see that here in a few minutes, and we'll bring that to you if we do. But tell us about the separation maneuver, because the apparatus, the actual... It's a really simple design.
It's a separation clamp. We'll talk about that in a minute, but as you see on your screen right now, you see the Mission Director Center where Omar Baez and the team are. And Josh, you and I joked about this a little bit earlier, but with the pandemic and everything going on, the teams have done a great job. Normally, spacecraft separation.
2020 with the Perseverance Rover, the Centaur will now perform its standard propellant blowdown sequence to inert the vehicle and complete today's flight after completing its CCAM avoidance maneuver. This will conclude today's commentary of the Mars 2020 mission. This is Atlas Flight Commentary signing off.
So that's the end of ULA's job for today.
Jesse Gonzalez did a great job with the ULA commentary this morning. But what I was saying about the Mission Director Center is normally we would see a lot of clapping, a lot of hoop-hollering, a lot of high-fives, handshaking. But with the pandemic and everything, people are staying their distance, taking the guidelines seriously, wearing masks with this. So we saw a lot of air high fives, right?
Yes,
and so,
absolutely.
So that does not take away from what the team is, how excited they are. They have done a lot of work to get to this point, and that seeing spacecraft separation is awesome. So, but
and throw on top of all that, 2020 was like, here, have an earthquake.
Right.
So it's just we did it. Like we're most of the way there, not there yet.
Yeah, as you heard Omar earlier in the broadcast say, a lot of us when we started this, when the pandemic started, we kind of thought Mars 2020 might be Mars 2022.
Yeah.
But Mr. Bridenstine and the NASA agency decided to move forward. The teams found ways to do this. As we heard, they were disciplined, they were focused, they were courageous. And all that played off today with a successful launch at 7:50, and now spacecraft separation, Mars 2020, Perseverance and Ingenuity on their way to the red planet.
Hey, we're going to wait for acquisition of signals. Stay with us, but really fast, Mick, tell us very, very quickly about this mechanism, because we teased it.
We teased it, yeah.
How do these things separate?
So the separation system is called a Marmon clamp band, actually designed earlier by Karl Marx, one of the Marx brothers. Very simple design, but it has some spring systems in it that once the signal is sent and the bolts release the clamp band, the springs basically just give just enough force to push the spacecraft off the front of the vehicle.
Awesome. And again, hopefully we'll see that video here momentarily. But for now, we're going to send it back to you and check in for one final time in a little bit with the folks here at ASOC. But Daryl, back to you.
All right, thank you, and great job, both of you, Joshua and Mick. It's always great to see Mick explain that springs are what's getting us to Mars. All right, so we've got our second burn underway. We've been flying for right about an hour, and as you just saw, spacecraft separation went well, and so that's fantastic. We can now say that Perseverance is officially on its way to Mars.
What a beautiful thought that is. And while NASA has been tracking the spacecraft since launch with its tracking and data relay satellite system, I know the mission control team at JPL is turning their attention to the next milestone, and that is ensuring that the array of communication antennas known as the Deep Space Network, or DSN, begin to receive a signal from the spacecraft flying the Perseverance rover to Mars. We expect to see the teams acquire the signal close to 9:14 Eastern Time. Though, as you saw, the spacecraft separation has occurred in the shadow of the Earth and out of line of sight of the system, so this could take a bit longer than estimated.
All right, and so finding life on Mars won't be as easy as you might think, and we talked a little bit about that. Here to talk about that and more is NASA astronaut Zena Cardman. Zena is here to join us, and we're so glad that you're here. Thanks for taking the time. First of all, your reaction to that launch.
Wow. Every time it takes my breath away. I had actually never seen a launch before until I got this job as an astronaut, and now I'm very lucky to have seen 3. And every single time, it just makes me feel so much emotion.
And kind of talk us through, I mean, it got up quick, right? So as you were watching it, you feel the rumble?
It did, yeah. First you see it go up, and then you feel the rumble as the sound travels to you, and you can really feel it in your chest. It's amazing.
Very good, very good. Talking about astrobiology now, you have an amazing background. You've searched for signs of life in some of the most extreme environments on Earth, the Antarctic, the Arctic. So you're used to looking for these biosignatures. What are your thoughts about this rover searching for signs of life?
Yeah, you know, we have a lot of experience looking for signs of life in unusual environments here on Earth. So if you take a look at Mars today, it's very cold and very dry, and we have some places on Earth that are actually a lot like that. So places like Antarctica or deserts. But if you want to look for signs of ancient life, life that existed billions of years ago perhaps, when Mars looked maybe a lot more like Earth does today, you have to know what those signs of life left behind in the rock record. Because microorganisms are very tiny and very soft, so they don't leave a fossil the same way a dinosaur would leave a bone or a footprint. So instead, we use these chemical signatures.
Daryl's dreams is shattered again. We told him there's going to be no dinosaur bones on there. He really wants them.
Something wiggling around, but no.
So why do we need to go to the moon before we go to Mars?
That's such a good question, because we've been to the moon, right? But we haven't been to the moon to stay. We really don't know how to live off of Earth on another planetary body, and we really need to figure out how to use resources, use tools, especially if we want to do geology on Mars. The tools that we use here on Earth are going to look pretty similar, but they might not work quite the same way. And because the round trip to Mars is so much longer than the round trip to the moon, when we go, we want to do it right.
Very good. And how do you like that rover behind you? Huh?
Oh my gosh, I love it.
Yeah, it's great. Hey, I want to ask you some social questions now. These
Absolutely.
are some from our audience who have been watching.
Oh,
so
great.
We appreciate you doing that. Our first question comes to us through Facebook. Thomas asks, will Perseverance land to investigate the landing site for a future manned mission in the same location?
Yeah, you know, that's a really good question. I think one of the most interesting things about doing a mission to Mars is choosing where you're going to go.
Yeah.
Because, you know, you can imagine planning a mission from Mars to the Earth, and if something landed in Utah versus landed in the ocean, your vision of Earth might be quite different. So one possible approach is taking a human mission and going back to somewhere where these rovers have been already, or maybe we'll decide to explore somewhere new. I have no idea yet, but I can't wait to find out.
Awesome. It looks like we have another social media question from Twitter, from Huda. Do you think that in a few years we'll be able to send astronauts to Mars in a safe way if we are able to send a rover like Perseverance to Mars in a safe and amazingly planned way?
I hope so. We won't go until it's safe for humans for sure, and we're not going until it's a round trip. But actually part of this mission, of course, is a round trip, and so we will eventually learn how to send a rocket to Mars and then have something lift off of Mars and come back.
Well, Zena Cardman, thank you so much for being here. You did a fantastic job. You're a great guest, and glad you enjoyed the launch.
Oh my goodness, it's impossible not to.
No doubt. All right, thank you.
Both.
Now, as you can imagine, there are a lot of systems to develop and prove out as we prepare for sending humans to Mars, as you just heard. Here now are 6 technology disciplines that are critical to the success of our future explorations. NASA's first Mars rover were powered by solar energy, but dust storms caused issues by blocking much needed sunlight. So NASA upgraded to nuclear batteries provided by the Department of Energy. And joining us now is the Assistant Secretary for the Office of Nuclear Energy, Dr. Rita Barnwell. Thank you so much for being here.
Great, thank you for having me. Excited to be here.
How did you enjoy the launch?
It was amazing, absolutely amazing. So fortunate to be able to be here and be invited to watch it. I'm just giddy.
Had you ever seen one before?
No, I hadn't. It was my first one.
And what did you feel as you were?
It was, you could literally feel the launch. So it was very exciting.
Very good.
Yeah.
So it's really interesting. When I saw this segment, I was just fascinated by the whole nuclear part of this. This is right in your wheelhouse. So explain to me, how did the Department of Energy get into the business of making nuclear batteries for space exploration?
So space exploration requires power sources for the long-lived missions that we need for this type of activity, for heat and electricity to be provided to the spacecraft and the scientific instruments. And nuclear energy can certainly provide that power. One source is the radioisotope power system, RPS. Part of that RPS is the radioisotope thermoelectric generator, an RTG. I know that's a lot of acronyms, but you got a decoder ring, so I hope you're good there. A space nuclear power system that converts heat into electricity without any moving parts. RPSs work by converting heat from the natural decay of radioisotope materials into electricity, and that's what we have up on the rover that just got launched this morning. It consists of 2 major elements: a heat source that contains a radioisotope fuel, mostly plutonium-238, and solid-state thermocouples that convert the plutonium's decay heat energy to electricity. DOE developed several generations of nuclear space power systems that can be used to supply electricity and use the excess heat for a variety of other space applications. This one that was launched is called the Multi-Mission RTG, and it was designed with the flexibility to be able to be operated on planetary bodies with atmospheres just like Mars, as well as in the vacuum of space.
It's amazing the longevity of that battery.
Yeah, I heard it could last up to 14 years.
Right.
Will it actually last longer than that duration?
It can, and actually right now it was 17 years, 3 years here, and then 14 years out in the mission itself. So we're very excited about that. That's one of the benefits of powering this mission with nuclear energy. The RPSs that are currently powering Voyager 1 and 2 that are exploring the extremes of our solar system also are being powered by an RPS that has lasted for 43 years.
Wow.
And so
that's a long time.
That's a great extent of time.
Yeah.
The MMRTG is essentially, it's a nuclear battery, like you said, and it contains only 10.6 pounds of plutonium dioxide fuel, and it provides 2,000 watts of thermal power. It's similar, the material that's used in this is similar to what was used in the 2 Viking spacecraft that landed on Mars in 1976.
Wow.
So this technology has been around a long time,
Yes.
and it's well proven.
Yes.
Dr. Rita Baronwall, we thank you very much, the Secretary, or Assistant Secretary for the Office of Nuclear Energy. Thanks for coming out. We're so
Thank
glad you
you.
enjoyed the launch, too.
Thank you for having me.
You're welcome. All right, here's a statistic you might not know about. Missions to Mars, roughly half of them actually make it there. Imagine that. But right now, we know the health of the Mars 2020 rocket is good because it's sending back a stream of data to our telemetry nerve center here at the Cape. Let's go back now to Joshua Santora to learn more about that. Joshua?
Yeah, thanks, Daryl. So we talked to Dr. Denton Gibson, who is one of the guys that works behind the scenes, but there is a group of folks that work behind the people behind the scenes, and Jessica Connor is one of those. She's coming to us now from the same Hangar AE location. Jessica, thanks for joining us.
Hey, it's a pleasure to be here. Thanks so much for having me on.
Yeah, so tell us about what you do to help make all of these activities, and as Daryl mentioned, the telemetry happen. What do you do for, what's your role for LSP?
So I work as a mission communications engineer for LSP. That means that I'm getting the video, data, and voice requirements from the spacecraft and then ensuring that they're able to go ahead and perform these operations once they actually get to pad phase.
Yeah, Joshua, I was just going to say Jessica's one of our wizards. You said behind the scene within the launch services program as engineers, we depend on our folks at AE to make sure that we get everything we need to do our assessments as engineers. So they make everything possible there.
Yeah, absolutely. So Jessica, tell us a little bit about how you get the data back and then how it's utilized out to the team.
So while it's on the pad, we go ahead and get that data through the umbilical lines, and then that goes ahead and gets back to the engineers, and they're able to provide fleet insight based on the data that they get from the consoles.
And can you tell us about how long you've been working this mission? People probably don't understand how much time goes in ahead of time behind the scenes to make these missions happen.
So I've been working for about 2.5 years on this mission. About 2 years out, we start working with JPL to go ahead and get those requirements, and then we've been working with them since to go ahead and get a processing video, and also being able to talk back to JPL, being able to talk to headquarters and stuff like that.
Awesome. And so what's been the biggest challenge for this mission? I know that this mission's presented a lot of unique challenges for all of our teams, but for you, where has that challenge lied?
So we have a ton of experience from different mission comm engineers from the past. And so the most unique thing about this mission has been our treatment of COVID. And it's amazing what we've done to go ahead and keep the control room safe for all of the people on console, and to go ahead and launch this mission on time and successfully.
Hey, listen, and we did it. We have the data coming back,
Yeah.
so that means that I think that means you did your job really well today.
I would say they did their job great, Joshua. They found new ways, as we talked earlier with the launch team, finding new ways to do their stuff. The folks out at Hangar AE also found new ways to make sure that all the engineering team could perform their fleet's insight assessments and support today's launch. So that team out there has done a great job. They actually make us in engineering look good. So we appreciate all the work you guys do, Jessica.
Yeah, awesome. Jessica, congratulations. Job well done. Thank you for joining us for this interview today.
Thanks.
All right, so Mick, things are pretty quiet now, and that's expected because we're just hanging out for the signal acquisition. The time there is the estimate based on the pre-launch data.
Yes.
Right now, we're actually in the shade of the Earth, so we're behind the Earth, and so we'll come out of that at some point shortly, and then hopefully acquire that signal because there's some solar rays that have to play in here. So still kind of some. I don't know if tense is the right word, but we're anxious still.
Yeah, I would say we're anxious. We're focused still. As I like to refer back to what Tori said earlier, right? Focused and disciplined. Even though it's pretty quiet right now, we have had spacecraft separation, which was a huge milestone for the team, an exciting time for us at NASA, ULA, JPL, the DOE, and our United States Space Force family. But the team is still sitting on console. They're still following their procedures. They're still performing everything that needs to be done as we await the acquisition signal. Some of the things that are going on here behind us is ground securing and everything here at the complex to make sure we can safely enter and do the work. So
yeah, very
a lot
good.
of work still going on.
Yes, and we're going to send you back to Daryl because we need to check in and talk to the folks who are going to be getting that data back. So Daryl will check in for one last thing in just a few minutes.
All right, thank you very much, Joshua and Mick.
Yeah, we are getting closer to our final critical milestone for today's broadcast, acquisition of signal. That will mark the official conclusion of the launch efforts by the LSP and ULA teams. I know my colleagues at JPL have been eagerly awaiting the first moment to see the Perseverance signal show up on the screen.
And it's exciting.
Yes, it is.
It's exciting when it happens.
Yeah.
Our mission managers are expecting that signal about 80 minutes after liftoff, so that's going to put that right around 9:14 a.m. Eastern time. So let's go back out now to JPL in California where things were shaking and rattling a little bit. Raquel, how does this acquisition of signal work?
Okay, Daryl, when it comes to making a long-distance call, it's hard to top NASA's Deep Space Network. It's the largest and most sensitive scientific telecommunication system in the world, and right now it's waiting for Perseverance Rover to phone home and let us know it's heading to Mars. And speaking of dialing in, Philip Baldwin joins us from his home. Philip is part of NASA's Space Communications and Navigation Program, and he's here to tell us how we communicate across the vastness of deep space. So, Philip, Mars is several million miles away from Earth. How do we get signals back and forth between the two?
Well, Raquel, we receive signals every day on our cell phones. And you can imagine driving out into the countryside and you're farthest from the nearest cell phone tower. And you look down at your cell phone, you see one bar, a very faint signal. As you mentioned, Mars is very far away, so you get a very faint signal, very much less than 1 bar. And so, thankfully, we have on the ground from our Deep Space Network managed out of JPL, very large antenna dishes that can detect that very faint signal. You're talking about a signal that's basically like an incandescent light bulb, and receiving that from millions of miles. We have 70-meter antennas and 34-meter antennas. A 70-meter antenna is about the size, to give some context, about the size of a 20-story building. So very large systems that can detect that very faint signal.
Great. And the Deep Space Network also communicates with all of our other missions beyond the moon. Now, how far have we gone into space?
Well, our Voyager missions are the farthest and fastest human-made objects that exist. Voyager 1 is nearly 14 billion miles away from Earth. It takes almost 20 hours one way to communicate to it. So once again, you can think about that light bulb. Could you imagine turning on a light bulb or a light switch and that light taking 20 hours to get to your eyes? And so basically, to communicate to Voyager, we send a command saying hi. It takes 20 hours to get there, and every 20 hours to receive a response from Voyager. So very far away. Thankfully, Mars is not as far away, as you mentioned, several million miles, not billions. So it takes not 20 hours, but it takes about 7 minutes. So it's a little better situation there.
Wow. So what does it take to add the Perseverance mission to the Deep Space Network?
Well, it's a lot of pre-work before the launch. We test with the launch vehicle. We test with the spacecraft. We test with the rover. We test over and over again to ensure that when it launches, when the spacecraft separates, when it lands on Mars, that we can have confidence that it will be able to establish a communication with us back on Earth. That's very important, and we instill that confidence by testing and making sure we have a lot of testing up front. And the payoff comes when we see those great, awe-inspiring images from Mars. And so a lot of testing happens up front, and a great team that works on that.
Great. Now, getting an acquisition of signal is a very significant moment. Can you tell us how it works and what we should expect to see for this mission?
Yes, that's a very important moment. And sometimes you'll see a spectrum graph that's a couple squiggly lines on the bottom, and what you expect to see is a peak in the middle come up, and that's what you call the carrier signal. And the carrier signal is described as a carrier because what it does, it brings in the signal. It carries the signal to us. Therefore, we can see that signal and know that we're receiving data. And basically, we see the carrier signal. But after that, we have to decode what the signal's saying. And hopefully what we're seeing is that the spacecraft is saying, hey, I'm doing okay. I'm on my way to Mars, and I'll see you there in 7 months. And so we expect to see that signal, and then we'll decode it and be able to get the health and safety of the spacecraft. But also what we'll also look out for is how to track it. So once we have the signal, we'll lock onto it. We'll move our very large antenna dishes. And as the Earth spins, we'll track the spacecraft around the globe. This is a global effort. We have our station in Canberra, Australia, and Madrid, Spain, and Goldstone, California, who will all be part of this tracking as the spacecraft goes to Mars. So very exciting time, and we're looking forward to hearing from Perseverance shortly.
Great. Thank you, Philip. Now, we are just a couple minutes away from the first opportunity we will have to see if the Perseverance signal on the Deep Space Network is up on our screens. That moment brings us one step closer to Mars, but we have many other milestones to hit over the next 7 months, and I'm with Perseverance's Chief Engineer, Adam Stelzner, who will tell us what's in store for the rover. Adam, what should we expect to see next?
Well, Raquel, we are... After we acquire signal, we have left the building. We are on our way to Mars. We're no longer in orbit around Earth. What will happen next is we will start our cruise phase. It'll be about 7 months before we make it to the red planet. We have a set of planned trajectory change maneuvers that we do during cruise to adjust our targeting. In fact, we're targeting to miss Mars right now. We're on the way, general direction of Mars. But in order to make our Atlas Centaur, which threw us in the direction of Mars, not run into Mars, we're on a missing trajectory, and we'll do TCM-1, which will target our impact with the Martian surface in a few days. So we start to monitor the spacecraft, make sure it's healthy and happy, and tweak its trajectory to be right on target by the time we make it to Mars.
Great. Thank you so much, Adam. And right now we are just a minute away from the acquisition of signal. So let's pause for a moment and watch our teams at work.
Today's flight will be waiting for indication of acquisition of signal. Ace copies.
Right now we are waiting for the acquisition of the signal from the rover itself, means the spacecraft I should say, and once we get that, we'll be like fully, you can say fully relaxed, not fully, but yeah, substantially relaxed that everything is fine with the spacecraft. So yeah, we are waiting for that right now. And the timeline for the acquisition of signal has already passed, but we still haven't received the signal.
20 MEM Reggie signed report initial acquisition.
Here we go. I think we have the
Copy that, radio science.
Flight nav.
Oh, here we go. We have the signal acquisition.
We're seeing one-way Delta. 34, so you say US.
Didn't copy nav.
Yes, sir, we see AOS at 131531.
Ace copies, thank you.
Flight telecom, I was about to pull up my contingency.
We now have an acquisition of signals. The rumbles now are of claps and cheers, and it's an amazing moment, and the years of blood, sweat, and tears from every person who worked on this mission is now realized as Perseverance makes its way to Mars. Now, if we still have Adam here, Adam, I want to know your reaction to getting the acquisition of signal.
Well, Raquel, it's very nice to have the spacecraft in a safe, separated, on its way to Mars. Nav looks good. We are hearing from the spacecraft. That was the only question. And it's not really much of a question, but it's just nice to have that confirmation. Our launch process is complete. The vehicle's on its way to Mars. And so the next chapter in Perseverance's mission can begin.
Great. And what are you looking forward to next?
I'm looking forward to, ideally, a very quiet and boring cruise to Mars as we prepare for the never boring and always stressful entry, descent, landing on the 18th of February.
Great. Thank you so much, Adam. And we hope you tune into our coverage of the landing happening on February 18th, 2021. Joshua and Mick, we here at JPL would like to thank you and the entire Launch Service Program and United Launch Alliance teams for all your amazing work today and all the work you do every day to make a launch like this possible. Now, Joshua, back to you at the Cape.
Raquel, congratulations to you and the team over there. Obviously, JPL, I think Adam's response is kind of what you'd expect from Adam of like, hey, check that box, but we got a lot of work to go.
Yes, yeah. I mean, the work here for the launch team, exciting day.
Yes.
We got this done. Our portion of this is done. Adam and the team now have Mars 2020 underway, and they've got a lot of work in front of them, too. And hopefully it is a quiet 7 months, and they get ready to go. But we are so excited to be able to perform this for them as our JPL customer. I know Tori Bruno and the ULA team are excited as well. And I just can't be, I can't be more excited about how this went this morning.
It feels good.
Yes.
Hey, before we sign off today, we want to check in with the NASA launch manager, Omar Baez, to get some thoughts from him. Omar, kind of give us your response after seeing a successful process this morning.
Okay, so about a minute ago, we did get acquisition of the spacecraft signal. That signifies that JPL's Deep Space Network has locked onto the spacecraft. It's on its journey to Mars. Everything appears to be going nominally for them. They'll get to check out the spacecraft now, do those checks that they need to do to learn how to fly that vehicle the way it wants to fly on its way to Mars. Pretty interesting. We separated them at approximately 25,000 miles an hour, and it's going to take a couple of months to get to that February 18th landing date, which they're targeting. So it's an impressive amount of speed that we imparted to them, and that speed is what our job as Launch Services Program and United Launch Alliance is to provide that spacecraft. The heavy lifting now is on our partners at the Jet Propulsion Lab. To slow it down when it gets to Mars, parachutes slow them down in the atmosphere and extend that sky crane and land on Mars. So they've got a heck of a lot of work to do from here on out. Today's count went beautiful up until the last 20 minutes. Started to get exciting with some of the assets on the range having dropouts. And then a surprise call from the a spacecraft mission director that we had a small earthquake in California at Pasadena that the folks in the control room felt. But they never lost signal, and they came back to me and said they were ready to proceed. We were able to lock down the time we were after, launched on time, perfect launch from what I could see visually here in the control room. The orbital parameters look dead on. Our velocity is dead on. So we're on our way to Mars. There's no way back. So good luck to the Mars 2020 team. It's been a pleasure to be part of this. I've been with this roving Mars community since Sojourner, and through Spirit, Opportunity, and Curiosity. So it's a pleasure to be once again part of that little bit that becomes that club, that auto club of roving on Mars. And I just want to say I'm very proud of this team. This team has worked diligently to get here. It's hard enough to get to Mars, throw in COVID. Today we're dealing with a small earthquake, the threat of a tropical storm heading in our direction. It's just an immense amount of pressure on the team, and it's so relieving to be able to have gotten that mission off today on the first attempt. And with that, that closes the show for us.
Awesome. A big thanks to Omar. Appreciate him and his words. Obviously, a phenomenal effort from all 5 of our teams we talked about.
Yes.
So from LSP, congrats to this team. JPL, congrats to the U.S. Space Force. Congrats to ULA. Thank you to ULA for hosting us today. And then the Department of Energy. And a special thanks to a couple groups, the RADCC and the JIC. Those were 2 teams that were working behind the scenes for over 3 years to prepare for a contingency with the MMRTG.
That's correct.
Didn't have to exercise any of that work, which is what they wanted. Like that's
So
kind of one of those
they
things.
had a great day.
They had a great day. Yes, everybody had a great day. So Mick, thanks to you as well for joining me.
Appreciate it, Joshua. Thanks for having me again. I've always loved doing this with you. And again, excited about the Mars mission. As Omar said, our prayers and good luck with the JPL team. They've got a lot of work in front of them, and we're just so excited to get them on their way in a perfect launch and orbit today. So thanks again for having me.
Yeah, the countdown to Mars continues. That's going to do it for us at the ASOC for the launch of the Mars 2020 mission with the Perseverance Rover. Daryl, back to you.
All right, Mick Woltman and Joshua Santora, thank you both. A great job done by you. And again, congratulations to the Launch Services Program team here at NASA for the great launch, as well as United Launch Alliance getting that off. And I got to congratulate you as well, Dr. Moo. You're with JPL. You've been working on this for 7 years.
Yes.
Congratulations. How does it feel?
It's amazing to have this phase of the mission cemented now in time. Is amazing. But like Adam said, there's so much more to go.
A lot of work to do, but you know that your baby right there in front of you is on its way to Mars.
Yes, it is.
Very good. Well, engineers and scientists at NASA have spent years designing, as we've told you, and testing and building the Mars Perseverance Rover, but we've also had help from a number of countries around the world.
Norway, France, and Spain, just to name a few, but also the European and Japanese space agencies. Here now is a toast to all of those who helped us get to Mars and help that Perseverance rover get ready to fly.
Congratulations for the successful launch of this fantastic new mission to the planet Mars.
Congratulations for the great work, despite all the obstacles set by COVID-19.
I want to congratulate everybody who made this mission happen thus far.
Thank you all for the passion and the commitment to make this epic happen.
Bravo et toutes mes félicitations, which means my heartfelt congratulations to all the teams involved in this magnificent adventure.
So you've been rewarded with a beautiful launch, and I hope you'll have a safe cruise to Mars. So well done the work so far. Let's keep going.
Skål to all teams for a successful flight.
Our international effort to reach Mars is more important now than it ever has been before.
This mission confirms that when we work together, we can overcome unbelievable challenges.
And to build a mission that truly deserves its name, Perseverance.
To persevere means to insist, to keep on, to continue trying tirelessly.
And if we persevere, we succeed. And that's why I think this is an appropriate name for this mission.
Perseverance has just started its journey to make history in Mars exploration.
It's the start of our collaboration, not only to go to Mars, but to bring back samples, the Mars Sample Return Campaign, and this is going to change our view of Mars forever.
Mars is an amazing place to explore.
Because exploration is inside the human being very nature.
Mars is essential to understand and know about our solar system, including our Earth.
We believe we can contribute to scientific discovery and future human exploration on Mars.
This exploration of Mars is of great global significance as it contributes to the humanity's search for a home away from planet Earth.
We need robotic precursor missions like Mars 2020 Perseverance to help us understand where we need to go and what we need to do when we get to Mars, but ultimately our objective as a globe is to put humans on the surface of Mars.
Together we're counting down to Mars, so go Perseverance!
一緒に火星に進出しましょう。行け、Perseverance.
Stiamo facendo insieme il conto alla rovescia per Marte. Vai, Perseverance.
Ensemble, nous retournons vers Mars. Bon voyage, Perseverance.
Hop Perseverance.
Adelante, Perseverance.
Hiya, Perseverance.
Together we are counting down to Mars. Go Perseverance.
And thank you so much to our international partners that you just saw there. They did a fantastic job. Now, before we let you go, we want to tell you about a little tradition that JPL has, where they did this, I guess, after the launch or before the launch with some peanuts, and Moo knows it well.
Yeah, in fact, Perseverance, a little baby Percy brought us some peanuts here to divvy out, so let me give you some.
Look at there.
It actually started with a landing event. So Rangers 1 through 6 didn't go as planned. And then with Ranger 7, it landed successfully on the moon. And they were thinking, what was the difference between Rangers 1 through 6 and 7? And it was these lucky peanuts.
The lucky peanuts.
Yeah.
And so ever since then, I guess they've been having peanuts.
Exactly.
To
for
get the
every landing, and now launches.
Well, and now we've got ours in our hand. We're going to hold off because we got a little more reading to do, but we're ready to go with our peanuts.
Yes. Yes, thank you so much for watching NASA's launch coverage of Mars 2020. Stay tuned to NASA TV and our social media channels for updates to the mission.
Yeah, coming up in just a bit at 11:30 Eastern Daylight Time, we will have a post-launch news conference right here on NASA TV, so stay tuned for that. And of course, to the next big moment that we've been talking about, the landing of the Perseverance rover on the surface of Mars 7 months from now. That date, February 18th, 2021. So for now, we leave you with highlights from the thrilling liftoff earlier this morning. Take care, everyone, and remember, keep looking up. Cheers.
Cheers.
7, 6, 5, 4. Engine ignition. 2, 1, 0.
0.
Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed loop control.
So yeah guys, this was the stream for the NASA Perseverance rover, and as you saw, it was a successful launch. So guys, thank you so much for tuning in. Be sure to tune in again for the Roscosmos launch, which is about to happen in about some hours from now, and we'll be back with that launch. So stay tuned, stay safe, stay healthy, and bye bye.